Hi, everyone. My name is Claudio. This is Alain.
Hi.
We're two engineers in the Google Drive developer relations team. Welcome to this talk. How's it going so far? Well? Good. We're going to talk about Drive and Android today. And, well, if you've been here yesterday, you saw a lot of things at the keynote about Android. If you've been here today, you've seen a lot of things about Drive today. We're trying to put everything together now. So let me start with a simple question. Can you please raise your hand if you use Google Drive? Woo! Wow, a lot of you use Google Drive. Can you please keep your hands up? Thank you. And then please raise the other hand if you also use Android. Wow, that's basically all of you. OK, please keep your hands up during the whole talk. Thank you. So you probably know all of this. Google Drive is the evolution of Google Docs. We have this product where users can store their files, and those files are accessible everywhere. You can store any kind of files. They will be safe in the cloud. We will take care of making backups and doing copies of your files, and it will be always safe. So it doesn't matter if you have files on your phone, and you lose your phone, or in your laptop, and you lose your laptop, it breaks, hard disk is broken, doesn't matter. The files will be there, and they will be safe at any time. But Google Drive is not just storage. It's not simply storage. You have seen this today. There are many applications on Google Drive. And we want you to use Google Drive to collaborate. So you store your files there. You can open those files with many applications, including ours, but not only ours. And you can collaborate. You can share these files with other users. You probably know all of this. So I'm going pretty quickly on this. But I'm pretty sure you've seen Google Drive, and you've seen a lot today at the keynote. So Google Drive, as you've seen today, is in your browser. It's also offline now, but that's a new thing. Google Drive is in your browser. Google Drive is in your desktop. And Google Drive is on your mobile device. This is a screenshot of Google Drive on Android. Today, we released the iOS version. But in this talk, we will cover the Android version of the application. And we will see how you can use the Google Drive SDK to write applications on Android that integrate with Google Drive. What is this Google Drive SDK? Well, it's an SDK, so it's a software development kit. It's a set of libraries, a set of methods, a set of classes that allow developers to integrate their own applications with Google Drive. Why would you do that as a developer? Well, there are many advantages in doing so. The first one is that as soon as you integrate your application with Drive, you already have a big, big user base. There are millions of users, and there are billions of files on Google Drive. So as soon as your application lands on Google Drive, you have a lot of users that can see, that can try, that can buy your application. And that is just the first advantage that you get by using the Google Drive SDK. You also get many other features for free. You get sharing. You get user identity management. You get collaboration. You get the integration with the UI, with the Google Drive UI, so that users can open files from there, can create files from there. You have seen some samples today at the keynote. So in this talk, Alain and I will show you how to take an existing application, which is a very simple Android application that you might probably know, which is a simple Notepad application. And that's exactly the first application that many of you have built if you've ever developed an Android application. This Notepad saves and reads files from the local database. So stores files on the local file system. That's actually using a SQLite database. And we are going to replace that or integrate that with Drive so that the notes will be stored to Drive, read from Drive, and synced with all the devices you have. Does it make sense so far? I hope so. So we were going to go through 5 steps. The first one is about how to perform authorization on Drive and on Android. Because there's a specific story, and we have some news today about how to perform authorization on an Android app that uses Drive. Once that is done, we will work on making the application asynchronous, writing a DriveSyncAdapter. If this is not clear now, don't worry. We're going to go through all of these steps one by one. Actually, Alain is going to go through the first 3 steps, and then I'll be back here and talk about integrating with the Drive app for Android, which you probably know and tried. And finally, we will also give you some more tips on how to optimize your application for efficiency. Remember, this is a mobile scenario, so you have to keep in mind different things than when you write an application for your desktop. So let's start with performing authorization.
All right. Thank you, Claudio. So first of all, why do we need to perform authorization? So as Claudio said, we have great user base on Google Drive, millions of users, billions of files, but the files belong to somebody. So that's why we need to get a user account to get started on Google Drive. So we're going to do that on Android by using the new Google Play Services API that have been announced today. They are not yet available, but they're coming soon. And we need to first start by getting a user account. So I don't know about you, but on my Android devices, I have multiple users. I have my corporate account, since I'm a Googler, and I also have my multiple Gmail accounts. Well, when you run an application that requires account information, it's best if the application can prompt you to choose the application to use, the user to use with your applications. So we do that by using the new account picker API, which has a simple static method called new choose account intent. This returns an intent that you can start from any activity you exported to show account chooser dialog that the user can pick from. So for our application, we need to run from a Google account. So we create a new intent. We might specify a saved account if we store that in a preference. And then we specify the account intent that we want com.google account. Then we simply start a new activity in Android, as you know how to do it. And we specify the request code the activity has been started with. Once the user has chosen an account, so perform any action on it, the onActivity result method will be called back by Android with the request code. So we need to make sure that the request code is the one we specified when we started the account, the intent, I mean. The result code is OK, so the user actually chose an account. And then we have data. Once everything's OK, well, we get the account name using the data and the static string provided in the account manager class. So how does it look like on Android? There you go. We simply use like 2 lines of code to start a new activity. This is a built-in intent provided by Google Play Services. The user can decide, can choose the account to use. And well, if the account is not there, can add a new google.com account. Now that we have an account, we need to authorize it to use Drive. The user needs to authorize their applications to get their Drive files and work with them. We're going to do that using, again, one of the new Google Play Services API called Google Auth-util. It has a static method called getToken, which returns an access token if everything works fine. You specify your context on which the method needs to run, the account name for which you want to get an access token, and the scope you want to authorize. So in our case, we want to authorize our application for the Drive file scope. The Drive API has multiple scopes, one of which is really broad. So the user can choose to grant access to its entire directory. While we don't really recommend that, because that can be a security issue, especially for Google, for example. We won't grant access to our entire directory. And like for any users, they might have private files like their tax information, et cetera, that they don't want to grant access to our third-party applications. So the Drive API provided a new scope called drive.file, which only grant access to files that have been created by this application, or specifically open with this application using the Drive web UI, or as Claudio will explain later, using the Android application. So we call getToken, hoping to get an access token. if the user never granted access to your applications, it will throw a user recoverable of exception. This exception will contain an intent, but your activity can start to show the user the grant screen so they can allow or deny access to your applications. Get token needs to be run outside of a UI thread in an async task or in our sample applications that we will release soon in a sync adapter. Now, when you start the intent, this is how the new grant screen looks like. Again, this is a preview. It's not yet available. It's coming soon in the SDK. So here we can see that Notepad, our application, is requesting access to the drive, to files that have been created by these applications for the account drivedeveloptest@gmail.com. So we didn't cover everything, any corners on authorization. There's a session starting right after ours at 5:15 from Yaniv called Building Android Applications that use web APIs. This session goes through how to register your Android application on the APIs console so that we know your application is authorized to use the Drive API. Any corner cases, like how to call get token in an async task. It handles errors if the user decided not to use an account or denied access to your application, and also explains how to cache expired tokens, because access tokens only works for 1 hour and needs to be refreshed when they get expired. So now that we have an account to work with, we need to unblock the UI thread. We will go from this. So this is a nice queue, synchronous. It's easy to understand. When you read sample code, it goes like step by step. But wow, it blocks the UI thread. We don't want that. Like as we saw during the keynote, we're putting lots of effort into making the UI looks good and not blocked. We want a sleek UI for every users that use Android and third-party applications. So we're going to modify the existing Notepad applications coming from synchronous applications to asynchronous applications, like that. It's going to be fast. Every task will race into each other, and it will leave the UI thread alone. How are we going to do that? Well, how many of you have ever seen this screen before? Yeah, it's annoying, right? Well, we need to take care of that. So why do we see this screen? It's because Android will kill any application that is blocking the UI thread for too long. The Notepad application is reading from the database in the UI thread, so it's quite fast. But the methods are getting deprecated, and we need to modify that. Also, since we're now integrating with Drive, we can't make the calls, the web API calls on the UI thread, because starting from modern Android, the system will simply kill your applications. So we have multiple ways to unblock the UI thread. One of which is using async task. Another one is using regular thread. In our case, we're going to use sync adapters pattern, because we're syncing our local database with Drive. Now, in this section, we'll cover how to write a DriveSyncAdapter. A sync adapter is composed of 3 main components. A content provider. So this is already available in the Notepad application. We already have a content provider that helps your application talk with the database and provides helper methods to insert new data, read data, make queries, etc. We also need a sync adapter service that the application will export and tells Android that this type of data can be synced with a sync adapter using the service. And then the main component, the abstract threaded sync adapter, which is the main class we need to implement, will contain all the sync logic. So we'll sync regularly the local database with Drive, or pull changes from Drive and store them in the database. We also added in a settings page so that the user can also change accounts and choose how frequently he wants the things to be performed. So let's take a look at the DriveSync service. this is a really simple class. It looks the same for most sync service you will implement if you don't have any special requirement. You just need to override two methods and create an onBind. So onCreate is called by Android when a new service needs to be instantiated, and onBind is called by Android when a new content needs to be bound with a sync adapter. So the onCreate method, in our case, we want a static sync adapter. So when Android instantiates a new DriveSyncAdapter, we simply instantiate a new DriveSync service. We instantiate a new DriveSyncAdapter in our static as a static attribute, and we make sure it's thread safe using a mutex. Now, onBind, again, quite easy. When it's called by Android, we simply return the sync adapters getSyncAdapter binder, which is the method already implemented by the abstract threaded sync adapter class. Now, as an activity or service in Android, you need to declare it in the Android manifest. So you do that by adding a new service tag in your Android manifest, add an intent filter saying that it filters the sync adapter pattern, and then link to the sync adapter resource XML declaration. Speaking of the XML resource declaration, here it is. So you declare a new sync adapter. You specify the type of content the sync adapter is able to sync. We're using the same authority as the sample Notepad application, which is com.google.provider.notepad. The account type for which data can be synced, in our case, google.com, since we're syncing with Drive. And then whether or not the sync adapter is user visible. This is a nice settings, and if you set this to true, the sync adapter will appear in the account settings page in Android, and the user can decide to turn on or off your service. And again, it comes for free. Now, the sync adapter. The main method to override is onPerformSync, which is called when a sync needs to be performed, as the name of the method implies. Account. So this is the account for which we need to sync data. There are some other parameters, and the content provider, which will help your class get data back and forth from the database. In the end, when you're done, you simply set the result in the sync result parameter to tell if everything goes well or not. If there was an error, Android will take care of trying again to sync, et cetera, et cetera. Why did we decide to use the sync adapter? Well, there are many things that come for free. If your device is offline, Android won't try to sync. This is nice. You don't have to handle that. If there's a failure, Android will try again. If you update your database and tell Android that the database has been updated, Android will know that a sync needs to be performed again and will try to perform a new sync, et cetera, et cetera. There are many things that come for free with minimum work from your part. Now, we implemented all the classes. Well, we didn't implement the sync logic, which will be covered later. But once all of this is done, you need to enable the sync adapter for your applications. You do that by, for instance, this is done in our settings page. We say that for this specific account, we want the sync adapter to be synced automatically. So all data will be synced automatically by Android. And then we also specify a sync periodicity. For instance, you want the sync to be performed every 5 minutes, 15 minutes, et cetera. And once this is done, well, this is what the account page looks like on Jelly Bean. And as you can see, the Notepad appeared and is actually syncing now. So we got an account. We enabled the Notepad application to use accounts. We authorized the applications to talk to Drive. We also started implementing a sync adapter. Now let's talk to Drive. So the Drive SDK provides an API. We recently released version 2 of the API yesterday. And the API is a full CRUD API. So it lets developers list, create, update, delete resources on Drive, which we call files. and other type of resources as well, such as ACL, which is sharing if you want to share your document with other users, etc. This is not covered in this talk. We are only using files resource because we're only syncing the database with the cloud. So now that our application is able to talk to Drive, we're going to first retrieve all the files that are available on Drive and has been created by your application. Why do we need to do that? Well, the user might have installed your application in multiple devices because your application is awesome. And you want all the files created by one application to be available on the other one. So we're going to list the files that have been created by your app and sync that with the database, local database. Then, if the user created a new file on his device, well, you need to sync it with Drive. So we're going to see how to create a new file resource on Drive and upload the content to it. Then we're going to sync changes, local changes or remote changes to a local database. This won't be covered in this section, but Claudio will talk about it in the end. And also handle deleted files. In case a user decided to delete a file locally, we need to make sure that it's deleted on Drive and vice versa. Now, how do we retrieve files from Drive? As I said, we're going to list existing files available in the user's Drive. We do that by first instantiating a new list request on the file resource. So this is a REST API, but we provide a client library that makes it a lot easier. As you can see, we instantiate a new request. This is a wrapper around an HTTP request with one line of code. We set a query parameter because we only want to handle text/plain file with MIME type. We have the list endpoint handles multiple query parameters that are available and documented in our reference guide. Once we instantiated that, we execute the request and get all the files that are available in the response. We iterate through all the items, get some metadata, such as the file ID, the title. We also get the content using the download URL provided by in the files metadata. So the download URL might be null in case if no content are available are stored in Drive. So those are some edge cases you need to handle. And then we store all of that in the local database using the SQL wrapper. And we iterate through all the pages, as there may be multiple pages returned by the Drive API. OK, so now the user runs the applications, get all the files that has been created already in his local instance of his applications. Now he created a new file and wants it to be synced with Drive. How do we do that? We create a new file resource, set some metadata, such as the title, set the MIME type. In our case, it's a text/plain MIME type. And then we also get the content of the file. We then call the insert method, which is also a REST API, HTTP REST API request, which is wrapped with our client library. So with only one line of code, you send both metadata and the content of a file to the API using what we call a resumable upload protocol. This comes for free for you, only one line of code. Of course, there might be API errors that needs to be handled and will be covered when we release the sample applications. Once this is done, the API will return some metadata, such as a file ID, that we need to store in our local database so we can sync, so we know which file has changed and can sync in the future. We also store other metadata, such as when the file has been created, when it has last been modified, et cetera, et cetera. Now, well, this screenshot doesn't really show you that it works, but let's pretend it works. You click on Save, bam, sync to Drive. Now, Claudio will explain you why it's interesting for you to integrate with a Drive app for Android.
Thank you, Alain. So you as users, as Android users, probably have the Drive application installed on your device, on your tablet. And that is probably the starting point whenever you want to work with one of your files. So you have to take that in mind when you write your own application. You have to consider that users can start from your app And in that case, you have to provide a way for them to access their files. But users can also start from the Drive application that we provide. And so every time they try to open a file that your application can open, and they try to do that from the Drive application, you can make sure that your app does that. How do you do that? The Drive application fires an intent every time you try to open a file from it. An intent that has specific parameters. So you can register your application in order to receive specific intents that represents files and operations your application can take care of. So every time you try to open a file from the Drive application, the intent will have a specific action that is called, there is a new one, a new intent action that has been just defined, which is called Drive Open. So if you want to receive that intent, you have to register, well, export an activity in your application that can receive intents whose action is Drive Open. But that is not enough. With Drive Open, when you register for that, you're saying, I want to listen to all kind of files. You can restrict that to some specific files. And for instance, you might want to restrict that to some specific MIME types. Our application, the Notepad application we are showing, only opens text files, plain text files. So we only want, or HTML files, which are text files, but we only want this application to listen to those intents that are for text files or HTML files. So we can filter that and specify that in the intent filters. And this is what you should export in your manifest. As I said, you have to export an activity that says, I can listen to the Drive Open intent. You specify the MIME type. You specify your application ID, which is number, an ID that you get from the API's console. And whenever you listen to one of those intents, you will also get a complete path that includes a resource ID. The resource ID or file ID is the unique identifier of the file the user is trying to open. So you get this intent, check if the intent is what you can listen to, and if it is, you have a unique identifier of the file, and you try to open it. And this is how you do it in your code. So you have to export an activity that implements this single method on create. When this is called whenever you listen to one of the intents you registered for. And so you get, first thing you have to do is to get the intent you're listening to. From the intent, you can get the action. Remember, we only want to listen to those actions that are Drive Open. So we just check it in our code. If the action is Drive Open, we do something which is specific for our app. If the action is not Drive Open, we probably want to ignore this intent. It's not what we're listening to in this specific scenario. So when the action is Drive Open, we check the resource ID parameter, and that is the unique ID of the file. And then we can use the same code that Alain showed before to open a file from Drive. So we have the API provides us with a method like service.files.get, which accepts a unique ID like this and returns you the file, as you have seen it. But there is a caveat here. When the intent is fired, we know what file the user is trying to open, but we don't know who the user is, because that information is not part of the intent. So whenever we get here in this part of the code, and we know that a user is trying to open a file, we still have to go through the account user dialog first. See who the user is. So ask the user to pick one of the accounts he has on his device, or create a new one, as usual, and then try to open a file. This is how it looks like. We're going to show all of this live. We have this application on our device. We're going to do a live demo at the end. So in this case, I started from the Drive application for Android and tried to open a text file. This dialog popped up and said that I have 3 applications that can open this file. And one of them, the last one in the list, is Notepad, which is our application. So if we click on that, then our file will be opened into our application. You're going to see this in a few minutes. Lastly, I'm going to give you some more tips. So I have actually 2 more tips for how to optimize your application for efficiency. Remember that we are in a mobile scenario. And in a mobile environment, when we're not on Wi-Fi, when we're 4G or 3G, downloading files can be very expensive and can be very slow. Files in Drive can be up to 10 gigabytes big. If you try to download one of those files with the best 4G available, it is still going to take more than 20 hours. So this is something we don't want to do very often with our mobile device if you're not on Wi-Fi. So we have to remember this when we design our application. And what we have to do is we only have to download files when it's necessary, when it's absolutely necessary. So we have to find a way to save bandwidth by using the local database as a cache. It's pretty obvious. If we have the same file in the local cache, we don't need to get it back from Drive. But we need to find a way to understand if the file we have in a local database is the same as the file that is on Drive. One of the fields in the file metadata that we can get from Drive is a MD5 checksum of the file content. So if we store that checksum the first time, the last time we downloaded the file, we can use it to compare it with the checksum that is coming from Drive the next time we try to download the same file. So the algorithm here is pretty easy. We send a request to get the file metadata. Then we compare the MD5 checksum. If they match, we only need to update the metadata. If they don't match, there's nothing else we can do. The file is updated, so we have to download it back from Drive. And this is how we do it in our code. This is part of the sync logic that Alain presented and that he promised me to show it to you. So every time we need to sync files, we have to be smart. And this is exactly the implementation of the algorithm that I explained a few seconds ago. So we're trying to push a file from our local file system, so from the local database, from the Android device, into Drive. So what we do is we have to compare the checksum of the local node that we have with the checksum of the file on Drive. If they're equal, we only send an update for the metadata. We're not sending the content. Remember, in our case, the content is pretty small. We only deal with text files. So the content can be, well, it's usually small. But remember, your application can sync videos with Drive. And of course, big videos can take a lot to be transferred. And remember that bandwidth is also expensive on mobile devices. So we want to be here in this else clause only when necessary. Here we have nothing we can do. We update both content and metadata. The library does this for us. We have 2 simple methods we can use. They look very similar. So we have this update method, and we're done. That's all we have to do. But we need to try to be in the first case as soon as possible, all the times we want. And here is the second tip that I want to share with you. Our application syncs, when it starts, it syncs all the files from Drive and copies them into the local database. Let's say in the future you want to sync again with all the files. Well, if you have nothing else than that, nothing else than those methods, all you can do is download all the files again, compare each file one by one with those you have in your local file system. See if they're the same, see if there are differences, and replace the old one with the new one. Same thing with deleted files. You have no way to know if a file has been deleted, then just check in a list of files and see if the file is there. Of course, this is is a resource-intensive process. It's very expensive. You have to download all the files every time you want to sync your local copy. But we're lucky. There's a feed called the changes feed in the Drive API, which returns the changes to all the documents since a given time. So this feed will say, starting from the last sync, last time you checked, starting from time X, this file has been added, this file has been deleted, this file has been changed. Everything else, you know it's the same. So you can save a lot of bandwidth just by using this changes feed instead of downloading all the files. You only download those files you know that have changed. This is also implemented by the library, and the usage is very similar to what we've seen with the files feed. Instead of doing service.files.method, which was list or insert or update or delete or anything, here we have service.changes.method, which is list in our case. So we want to list all the changes starting from a specific change ID. So all the changes are numbered. So if you last time synced at change ID 200, next time you only need to remember to sync from change ID 201. That's it. You get a list of changes, and for each of them, you just need to check if the change was a deletion, and in that case, we sync the local copy of the file, so we delete the local copy of the file. Or if it's not a deletion, that is an update. And so we get the file, and we do the syncing, which is updating the file or inserting the file. Of course, we have to do it for all files, but I mean, that's just a do loop. I don't think there's nothing to explain here. With this, I think we can move on to the demo. And we're going to show you the application we built that does everything we showed you. Let me switch.
Is it on? Yes.
And it is.
Am I on? Yes. So thank you, Claudio, for those performance tips. This is a live demo. I'm on Wi-Fi, so that can be wrong like in millions of manners. So as I can see, I don't have much Wi-Fi connections. Apparently, I'm connected. OK, let's try this. So I opened my Notepad applications. As you can see, this is the same as you implement if you go through the Android tutorials. List of files, nothing new here. Then we added a preferences page. We go there. As I mentioned, you can choose the account you want to use with your applications and also set the sync frequency. So now let's try to choose another account. As I explained at the beginning of the session, this is using one of the new Google Play Services API called Account Picker. With one line of code, you get an intent for free. The user can choose to use another account. Let's try a third one. OK. This account has never used this application before. So my sync adapter tried to get an access token. It failed, get the exception. And now it's sending a notification to my user to grant access to the app. I click on it. It's on Wi-Fi, so hopefully it's going to work. This is checking if if the user ever granted access to my application before. Now I get the approval screen. I can carefully read the text. Of course, everybody reads the text. And then decide whether or not to grant access to the applications. Well, in fact, I didn't want to use this account, so I'm just going to cancel. And go back here and choose the account I used before. Now, for the sake of a demo, I'm going to put the sync frequency every 5 seconds. This is not recommended, of course, but well, this is a demo. Now, let's open a file. Which one? Let's say the first one, to-dos. So we talked about how to get an authorized account, implement the sync adapter, talk to Drive, talk to the Drive API to sync data, and also use the changes feed to improve performances. Now, what else do we need to do? And join.
Okay.
Bam. Let's save. So now this is saving to the local database. The syncadapter knows that the local database has changed and will try to sync again, using the syncadapter. Now let's use the Drive applications. Hopefully this is already synced. So trying to look for changes. Let's wait. I want to show you that it actually synced, because otherwise I can fake everything. Well, as you can see, to-dos has been updated at 4:41, 1 minute ago. Let's try to open it with another applications, because if I open it with mine, well, I don't know, I might be faking the database. So I won't be proving you that I've been using the Drive API. So let's say I'm using the document viewer. So opening the file, this is getting data from Drive and launching the application. As you can see, we can now enjoy syncing files to Drive. Ooh, this is working. Yeah. Come on. Thank you. All right. Well, this is awesome. I can create new files on Drive, get data from Drive, sync. This is perfect for any type of applications. Gamers application, for example, like you want to have saved data, syncs across all devices. Get that for a few lines of code. Now, I can notice here that I have a note that is not sync on my notes list. Why is that? Well, this is a text file that has been created by another application, not by mine. So my application is not authorized to read it unless the user specifically approves this file for my applications. Well, with a Drive app on Android, you can do that as well. So I'm going to click on Final Notes. This is firing an intent on Android, looking for all applications that handle the Drive open intent. And my Notepad implemented that. So let's open it with Drive. Oh, with Notepad, sorry. Opening, what it did, it sent a request to our backend saying that Notepad applications is now authorized to read and save data to this file using this application. Now, well, as Claudio mentioned, I don't know which user fired the intent, so I need to prompt the user to choose the account to use. We are working on improving the story, but bear with us. For now, this is the best way to do it. I'm choosing the second account, which is my test account. And now I'm pulling data from Drive. Again, this is on Wi-Fi. Hopefully.
This is when they clap their hands, right?
Yes.
For real this time.
Oh, there you go. It worked. Isn't that awesome? Then I go back, come back to Drive, go to my Notepad applications. As I can see, Final Notes is right there. Now my application is authorized to read this note. Few lines of code, you get accounts authorization, background syncing, and you talk to Drive. Now all your local files, all your local data is now synced to the cloud for only, I don't know, a few lines of code, 100, not even. We won't be releasing the simple application right now because the Google Play services will be coming soon. So some dependencies are not yet available to you. When it is, we'll show a tutorial. We'll write a tutorial on how to do that, how to update the Notepad applications, and provide a full sample code for you to work from.
Thanks, Alain. And with that, I will just show you the link to our documentation page, which is at developers.google.com/drive. It already talks about writing Drive application on Android, but as Alain said, some pieces you need are not there yet. They will be available soon. There are some pieces in the Google Play services, but they should be available soon. And you also have our contacts, so our email addresses, our Google Plus accounts, and my Twitter account. And if you have any questions, this is time to ask them. And if you do, please use the microphones there and there. As an incentive, we might have some swag, which might be either a T-shirt or a self-driving car.
Yes.
You'll never know.
We haven't decided yet, but if you want to know,
you pick.
Ask questions.
Question.
You are first.
So now we can also save some work offline with Drive?
So this application which we developed works offline, because every time we do something in our application, it saves to a local database, and then it syncs. That's one of the advantages of using a sync adapter. And as the sync adapter takes care of all the syncing, so you only need to know how to write to a local database. And then as soon as you have Wi-Fi, as soon as you have connectivity, and if the sync adapter is enabled, then syncing will be done. That's why we implemented this sync adapter pattern.
So what's the guidelines for sync adapter? Because let's say if I have two devices, I'm modifying the same file on two different devices, and they are offline. One line is changed differently on one device, same line is changed differently on other device.
Sure.
What are the recommendations to handle this?
So, of course, the first device to be connected will push its changes first, and then the second one will try to push its changes first, and it's up to the sync logic you implement in your application to merge them. So, in our application is pretty simple, and we don't really do like line-by-line diff or merge on anything fancy.
I think we're doing last come
Yeah,
win.
so we basically lose the first change if there are two concurrent changes. But this is a limitation in our application. It's up to the developers to implement a sync logic that takes care of that.
Okay, thanks.
Thank you.
He was next.
Oh, sorry.
Okay, so if I understand correctly, this is kind of replacing C2DM, or is there a way to integrate that so we don't need to set the time in the refresh settings?
So I don't know if you went to the Drive talk this morning from 11:45. We are working on adding push notifications to the API. So this will go probably through C2DM. I don't have detailed implementation yet. It's going to be available. Right now, it's not. So your applications have to pull data from Drive. And the best way to do it is using the changes feed, because you don't get the entire user's directory. You only get files that has changed since the last sync.
One more question. You said everything right now is not available yet, but do you know if it's going to be added to the Android support library so we can use it in older devices?
That's a good idea. We're going to talk with the Android team, and whether make it available on the Android SDK or make it available in a separate repository, but it's going to be public and open source.
Yeah, and the plan is not to only add it to the last version, Jelly Bean, but also to previous ones. We don't have details yet, but that's what they're working on right now. So seeing how this can go down to other versions so that basically all devices can have it.
Okay, thank you.
Thank you.
Looking at your example code, you were showing the account user every time. Would you recommend developers steering clear of retrying the last account selected, and is there a specific reason why you try and steer clear of retrying that, looking for an error, and then presenting the account user?
Well, in our sample app, we store the chosen account in the preferences. So we simply store the name of the account, because we only need that to get an access token. If we have that and the user is trying to change account, we prompt the screen, the dialog, and tell the intent that, well, the user previously chose this account, so please pre-select it. In the case of when we're opening a file from Drive, we don't know who opened the file. So we could use the preferred account. We didn't do that, but that's a good way to pre-select an account. Otherwise, it's up to the developer.
But that's actually no guarantee that the last user selected in our application is the same user that is opening a file from the Drive application.
But would there be any difference between separate users who both have read access to a file, opening
Well, you
the
don't
file?
know if the other user has read access.
But you'd get an error message back, at which point you could present the
Well,
account selector.
another approach could be to try and see if the user can. But then if the user can't, you don't know if it's because it's a wrong user or if because there is some other problem, let's say. So I would say that right now the recommended approach is to show the dialog every time when you start from the Drive up. But as Alain said, we know this is probably not the best user experience, so we might change this.
Thanks.
Thank you.
Hi. Sorry. Hey, so if you want to use Google Drive to hold, say, a text file for, like you said before, a game save or settings for your application or something, is there any way that you can prevent the user from using anything but your application to access that file?
Sorry, can you repeat the last part of the question? Prevent the user from?
Accessing it through Drive or whatever else and modifying it.
So there are multiple tags, tags in the file's metadata that you can set, and one is hidden. So you can set a file as hidden, so it won't show on the Drive UI, but will still be accessible through the API for your application.
But
awesome.
In that case, let's say a smart user will be still able to access it, right?
If a user search for it in the Drive UI, it will appear in the search result, but it won't appear by default.
So remember, the thing to remember here is that Drive is user-managed storage, so the user has final decision over his files. You cannot just create a file and prevent him from, let's say, deleting or tampering with it. So if that is a problem, then Drive is probably not the right solution. But I would say, I mean, it's up to your app, but I would say then just remember that. There is no real way to prevent that. The user can always override your settings.
You mentioned there was a dependency on the Google Play Accounts Manager. What was it called? So is there a time frame for when this will be available?
It's coming soon. Even us don't have all the details because it's from Android, but it's coming soon. If you went to the talk yesterday on what's new in the Android SDK, or if you watch it again, they will talk about it. And also, if you go to the session we mentioned, writing.
So right after this?
Yes, building Android app that talks to web APIs from Yaniv. He will also mention those new APIs from the Google Play services.
So actually, the section that we're mentioning is specifically about this authorization part, which is part of these new Google Play services.
Okay, as a second part to this, during the demo you showed that whenever the user needed to give authorization at the very beginning, there was a little notification thing at the top.
Yes.
Is there any way to make it come forward to the foreground?
Of course.
As opposed to, because I think most users won't notice this. Because even during the demo, you got other notifications at the top. We didn't know, I didn't know if this was related to the app or not. How would we let the user know? So
I decided to use the notification system because, well, it's less invasive to the user, but it's coming from the background, from the syncadapter, and you can also decide to start a new activity instead of pushing a notification to the user. So this is up to your application.
Thank you.
Thank you. Any other questions?
Anyone?
Okay. With that, thank you very much. And